So the first thing is that this is done at extremely short notice, and I think I should get rid of this. So is the screen okay? Can people see the
Yes,
screen?
it's good. It's very good.
Okay. So there's a number of caveats that I want to do. Is that first of all, this was done at extreme short notice, and some of the slides were done rather late last night. Mez was telling me, I asked him to have a look, that he got his email at 11 o'clock. So my brain might not have been in the right place. So Mark has well and truly set me up. The other caveat I'd like to do about this, and this is something I've been playing with for internally for a while, is that what I'm going to talk to you about is a case history. So it's warts and all, and it's definitely not meant to be best practice. And I think the reason I hope you find it interesting is because it'll look more like the work that all of us do, because everything starts off a bit of a mess and then you start tidying it up and eventually gets a little bit better. So if you see things that you think could be improved, that's really good. And if you can share it, that'll be good. I'm happy if people interrupt. Also, I should warn you that the topic of the data engineering topic is not my field. I know there are a number of people. I think Al's an engineer. I'm pretty sure he is. David Leal's an engineer. Mez is an engineer. So I may need to call on SMEs to explain some of the technical details. Hopefully, I can just about master the data details. So let me just check. Have I done? The other thing that I think I would be interested in feedback from you on is, so one of the problems over the years that we found from mining ontologies is that a lot of interesting stuff is either in text or in form, or even if it's in tables, the tables don't show the explicit underlying ontological structure. And one of the common things is a form structure, and I'll go through that during the presentation. And the thing that I think is intriguing about the form is that I think there is an implicit syntax in the form, just like there's an implicit syntax in natural language. And the trick is trying to find a way of getting it out. And the interesting thing with the data sheets, particularly when they're standards for data sheets, is that you've got this opportunity for scaling up. So if you can find the implicit syntax for a particular type of data sheet, you can run it over all the data sheets. And that's, in a sense, one of the interesting things behind this project. So let me zoom on, just in case. I'm not sure all of you know, but just in case, I think most of you do. uh, um, the important thing is that I think these might have arrows coming in. Oh yes, is this thing here, is that Borough's actually got two parts. It's the foundational ontology, which I think gets a lot of press, and there's also this bCLEARer methodology, which is a mechanism for getting the ontology out of the existing data. Which, and I hope once you think about it, they're both required, not just one. Um, I've realized I hadn't really said much about it. Let's see what happens to the second arrow. Is that I think we were one of the first formal ontologies in early IS. We started work in the late 1980s, and then eventually I think the book came out in 96. It took 3 or 4 years to write. So the book was sort of behind what started. I'm not sure I think when I started, in fact, when I read the book, I was told not to use the word ontology in it. But when I started, I don't think there were many. I didn't know of any other people working in IS. I mean, not that I had a large network, but there weren't any there. The other thing that's a bit different is it's always this, all our work has been driven by commercial projects. And I think that's quite important because you get feedback about whether something works or not pretty quickly. Right, so let's zoom on. This is a little icon we're trying to do to try and even explain what's going on. Is the foundational ontology gives you a sort of like a top-down framework, a goal of where to aim for, and bCLEARer is the bottom-up framework, but they interact in interesting ways, I think, compared with some of the other ontologies, because bCLEARer tests whether or not probably some aspects of the very, very top, but as soon as you get down into the domain, you can see whether it works or not. You've got a way of validating the model against real world data, and hopefully that real world data, if it's from an operational system, connects with the real world. This is a slide that probably Mez would recognize. He was helped produce it. Is that the two methodologies can interact in all sorts of different ways. You can configure them to do different things. That's just what this is meant to show. This is, if you like, me being moaning a little in some ways, is that if you look at the the way the standards community has interacted with the work that we're doing. There've been quite a few standards. I mean, Matthew in 1596, right from the start, there's a lot of credit for realizing it was good. Ian, I don't know, Ian's not here today. I don't think any of the Telesync guys are here. Ideas, MODAFT and DODAF and so forth, and UPDM, and now IES. Well, the IES guys deserve a lot of credit as well. But I think they've engaged with the foundational ontology, and you can understand from a corporate perspective, it's something that's got a structure. But I think bCLEARer is in some ways more interesting, or a foundational ontology without some way of mining the ontology, I think is I don't know, is only half a solution. And it's intriguing that there, if you like, in terms of engagement, people are happy with the foundational ontology, but for some reason there's less engagement with bCLEARer. And you'll see what goes on today, and maybe after seeing an example of bCLEARer at work, you'll think that they made the right choice. I'm not looking at the chats. Should I? If there are questions, Mark, that they're good, I'm more than happy if someone interrupts and asks them. I'm not.
Let's leave them to the end, Chris, because
Okay.
they will definitely come up.
Okay. So then the other thing, I like this as the user perspective. They can see the mess before, and if the projects work, they see something pretty afterwards, and then there's something happening in the middle. And this is going to give you some idea. We spent ages trying. I think it's very difficult to try and divide up the process of mining ontology, because there's so many different ways of doing it. And even now, sometimes the categories don't quite work, but it's useful to have a structure to organize things. And this is the structure that we've got. It's an acronym. The idea is that it's a repeatable sequence of automated processes. So the big issues here are scale and cost. You want to reduce the cost of running it to a stage where you can if you have to run it 10 more times, it doesn't cost anything. You don't worry about it. You also want to have it sufficiently low cost that after the first run, if you see big improvements, you've still got budget left to do it. So the big idea, I mean, if you look at the lean startup and sort of those kind of mentalities fits in, and the end is this single foundational ontology. And if the Borough foundational ontology provides if you like, a framework for getting your single ontology. This gives you probably, if you're more business oriented, a bit idea of going on. You get multiple systems coming in, and then you get an overall picture in your single integrated picture coming out, and then you can get a series of sub data sets that you ship out to across different products. And then when you do this, your semantic interoperability between the products is higher. You can go with bCLEARer, you can go in, and this is a different mentality. You can go in stages, so you might stop at the entity stage in your first project, and then the second project you might go on a bit, and only in the final project will you look for going for the full repository. In the early stages, as you go further down the stages, the overall structure becomes guides you more. In the early stages, it's more about tidying up, but it does help to have the background picture. So datasheets, the topic of the day, are one part of the overall legacy engineering standards territory. If you're faced with it, you've got to start somewhere. Datasheets you could argue, are a reasonable place to choose. I mean, one of the reasons is that you can see them as from a certain perspective, they start of the data trail. Normally, people will consult the data sheets to put the data into the other systems. Eventually, you're going to have to look at the other systems because you want to integrate a picture across all of these. One of the uses I think people using this have found is when they start to populate their new systems, if they know enough about the data in the data sheets, that can influence how they set up the systems. For those of you, maybe one or two who are not sure of data sheets, this is taken out of Wikipedia. It talks about the people who use it. What was interesting is I think it's the data sheet is typically created by the manufacturer, but one of the things when I was reading this, and maybe some of the engineers can quote, is I think it's used at all stages, because obviously it's used for purchasing, but I think at maintenance, people like that look up the data sheet to find out what's going on. I mean, we do that at home. If I don't know, your whatever it is, your something or other, your toaster goes wrong or whatever, you try and find the manual to try and find what's going on. I was amused by this. This is in Wikipedia. The ideal data sheets specifies characteristics of formal structure according to a strict taxonomy that allows the information to be processed by a machine. As we'll go on, I think I've got an example of an ISO standard. I think this was I think there was a link to some company here which claimed they were doing it, and I'm sure they are, but I think it's few and far between that people are at that level of maturity. Oh yeah, this I think is taken from an ISO standard. Uh, it's as a normal ISO standards, and David might leap to ISO defense here, but it was I mean it was reasonably well documented, but I'm not sure there was much of a taxonomy around. And what's interesting, if you think about what's happening, we're going to show later, if you look at, let's say, I hope you can see my cursor, you've got radial bearing and thrust bearing, and then you've got this merged cell which goes type size, and then you've got these two cells here. So there's a whole, and then you've got this one above it, total clearance, three things, and then stuff with millimeter. So there's quite a lot of implicit structure in here that I think a human can read. And if you know the sheet, that's why I say human engineer readable. But as you shall see, it's a non-trivial exercise. I mean, it's something I think the other Partridge on the call, Peter Partridge, probably has with his Jane's work, is how do you get, there is a structure there, how do you get it out? General points about it, there are standards, but there are a whole number of different standards that are done in different ways. Generally, as a low level of digitalization, we looked at API. One of the things we looked at API standards because they're in Excel, which is at least a start. We have in the past worked a lot with PDFs, and particularly old PDFs are bad. And if they're scanned PDFs, I mean, some of the OCR is getting quite good, but it's not brilliant. We found that if you look at some of the sites have got quite old equipment, so the legacy data sheets are less organized than you'd expect. So in bCLEARer over time, one of the things we have at the first stage is where you collect the data and then you load. So one of the things that you want, we try and do when we do collect is we'd like our data to be as structured as possible. So if we've got a choice between data that's in unstructured data and structured data, we choose structured data. And also we need to tailor the processes to what's going on. And we sort of formed these rough three categories of stuff that's coming in. So data is structured, so we're not going to have to worry about structuring it. Text is to be avoided if possible. If not, it's tricky to try and do it, though LLM stuff may or may not help. But forms often come in, and the problem here is how you deal with the structure. Most tables have some form aspects. They have some merged cells, or they actually have the individual cells actually have structure inside. So there's an element of forminess. But when you get a proper form like we're going to look at today, is that there are various challenges, and hopefully what I'm going through will explain what the issues are. And the big point is there's a lack of explicit machine readable structure, and it's a question of how you add it. So just to try and make the difference, the thing on the left isn't quite a table. You can argue it's a form because, for instance, you've got the unit of measures stuck in the column headings. You've got some data which you could, in terms of the first row, the type, you could probably 750 times 137 probably means something, and so forth. But this is more of a table structure. The thing we're after is this more like this data sheet with far more merged cells, so far more if you imagine this is stored as an Excel spreadsheet, it's structure that the Excel code doesn't have. So it'll know, for instance, that output gauge pressure is either a merged cell or it could be two cells, but you can't tell until you look inside with a border around it. So some of the stuff you can get access to, but some can't, but how it's related. So for instance, it's claimed that output gauge pressure is related to rated, and it's related to this thing where, I hope people can see my cursor, where bar is, whereas density at OT, even though it's on the same row, is not, it's irrelevant link to output gauge pressure. Just to show that it's forms aren't something new. This is the Linnaeus classification, and you can see the same thing here. The emerged cells. There's places where they haven't got borders. If you go across here, there's a line that goes across here. I imagine part of it was the cost and flexibility of their various printing structures for going on. But it's intriguing. Even at this stage, they could do forms. It wasn't such a flat, unstructured text. Okay. If for these kind of things to work, you've got to be very flexible, and you need to think in terms of driving down to low cost processes. So the lean startup's a good mindset. When our guys got a hold of this, there's a lot in the lean startup that resonated. It's also good to have a staged approach, and the agile's a good model, and particularly this idea of an alpha stage where you're exploring the possibilities so you don't know what's going on. And the presentation today is very much of something at the alpha stage. I think even at the beta stage, you should look for evolutions or pivots. The other thing which I think comes out of the lean startup, if I recall correctly, it's a while since I read it, is you have a soup to nuts, you have a product at the end. So you're trying to get your product as soon as possible so you can get feedback whether it works, and then you involve the product. So it's more important to get to the end of the pipeline with an output and then start evolving, then try and make sure each of the bits of the pipeline work well. We've go different ways on this. Is that we've been all sorts of shops at the moment. We're a Python shop. We've tried Talend and Nime more than Alteryx. We find that for stuff that you want to do really quickly, Nime is a lot, or Nime and Talend are a lot quicker than Python. But when you want to start scaling up and industrializing, Python becomes better. So, and in the project we're looking at, it's an Alteryx project. So it was probably the right choice for the early stages. Python will be probably a better stage later. And one of the other things, hopefully I'll try and remember as we go through, is you're trying to clean the syntax before exposing the semantics. So you want to have a really clean syntax before you start worrying about the semantics. Just to give you some idea of the structure, there were datasheet specifications, particularly from standards, and mostly focus on Excel spreadsheets, though there were some PDFs and other things. You wanted to triangulate on, particularly for some of the UOM stuff on ISO quantity. So you merge these two together, you give a framework, and this gives you a framework then for reading the actual data sheets that they're themselves. And what you want this to be is you want to automate this pipeline. So there'll be manual work where you configure the pipeline and get it working, but the idea is you can run it as many times as you like and at low cost. Just the structure, there was an Alteryx backbone, we do things, visualization important. There's some Cyto stuff in here, Cytoscape stuff in here, but mostly Neo4j on the outside. So you can visualize. Visualization is really useful way of just trying to get feedback of where you are. The other thing that we found over time is that, in a sense, a lot of our time when you're trying to extract the semantics out of or extract an ontology out of a data set, you really want to get the ontology really clean. We found that it's a good idea to get the code that's doing the extraction really clean as well. This is just a nested Alteryx process here, and we're fans of Robert Martin clean code and the stuff he does. I think he's doing something slightly different, but his heart's in the right place. He's doing the kind of thing that's really important. And we find this makes a big difference, particularly when we want to evolve. So if we've got something that's changing, rapidly all the time, you might think, okay, don't clean it, because then when you change it, you're losing the cost of cleaning. We find if you don't clean it, when you try and change it, the cost of any change is so high that it gets difficult. And in fact, the cleaning the code process is actually part of the evolution. You begin to see the issues. It makes the issues much clearer. Two sources for the standards, two examples. I mean, this is an example of the different standards and the way they work in different way. The ISO standard is a PDF with a table inside it. I wonder whether the table was done in Word or the sheet was done in Word or Excel. A lot of the API stuff is done in Excel, which is better, but both you give you an indication of the kind of maturity that these places are at. The reason I'm just shoving it in, this was an analysis of the sheets that get in. If you look sort of about 800 going here, give you some idea of the level of variety, and you can see across, if you go across here, they've been roughly put into broad engineering categories. So you've got some idea of what's going on. Oh, some idea of the scale here. So to reiterate again, this is a case history. It's not meant to be an example of best practice. It's at early alpha stage, and I think reporting this is really useful because it gives you a feel of the issues and the problems. Well, if you're working in this field, it will give you, it may remind you of certain things, hopefully not too many nightmares of the thing that's going on, but at least it's being honest about the kind of things that's going on. And that one of the things that we want to do here is we're looking for there to be further evolution development of this. We're expecting there to be major pivots in the way it changes. The way in which, so one of the things they decided early on was trying to decide on if you like, a language, design a language for extracting the informal structure. And they made a decision to go do something as simple as possible. They were using engineers to do this. They're not particularly well trained in data. So what they said is that we're going to assume behind the, and this is particularly for the API in Excel, we're going to assume the Excel grid. So our units are each individual Excel cell, and the only relationship we have is an ordered relationship between cells. And we type the cells. That's all the language you've got. The benefit is it's really simple. And the problem is that it's really simple, but at least you're getting some idea of the scope of the project. So you know for a cell, you know which row and column it is in, and then you classify the cell and you do relations between it. And you'll see examples of this as we go through. I'm not, Mark, how much time have I got left? There's a lot of slides.
Yeah, I think just a couple of minutes, Chris, because I'm there's loads of chats, loads of conversation to
Oh,
have.
okay.
So
So
maybe if you just,
I'll zoom really quickly then. Okay, so in the load stage, all you're doing is you're trying to put identity on the content. So basically what you're doing is we have a way of, we hash up the content so we know what content's there. So we say this is the explicit structure that we're working with. So at this stage, you've got an explicit structure, an explicit way of doing it. And we find a way of hashing it. So if we were to reload it and the content had changed, the hash would change. This is what happens in the early evolve stage. This is where I talk about you add the classifications and you change the classifications, which are down here, and you add the parent-child links. And then at the end, you can visualize this. As I said, this is a Cyto visualization. Many of the others were Neo. This is an early basic model. So one of the things we're in the process of doing now is trying to get together, if you like, what the general model for forms are and what the specific model for the specific data sheets are. These are the kind of classifications that the engineers came up in terms of what they were doing. Give you an idea of, some of these were quite small, some of these are much, much bigger. A visualization of the types. Again, at each stage is amazing how, if you're working on it, how much a visualization can make a difference. I'm sure a number of you here would agree. So this is an idea of what's going on. So one of the things we do is this cell here, general, will be classified as a property, that cell classified as a data sheet title, that classified as a purpose, that classified as a sub property, and the link between properties. So general to manufacture, there'll be a link in there. And so forth. And these are more links as we go through here. Again, this particular thing, if you look at this thing, actually, let's go, it's here. Okay.
Chris, I wonder if that might be a good time to invite the comments and the questions.
Can I just do one more, just
Yes,
one
yes,
more thing?
certainly.
Sorry, just this or two more things. So this is various questions that were arising. So what you can see is this is where the pressure of the doing the work, what should go on. So in this case, they're saying, oh, we expected the cells to include string characters, and in fact they're going to include a boolean. How do we do it? So they entered a new cell type, and let me go zoom through here some more. This is about checking the names, more checking the names, doing everything else. But I think there's something at the end. This is bringing the ISO standards. There's yeah, here again, this is quite useful because what it's saying, if you just look at this thing here, available fault current, you look at it, you can see there's this structure. So this is behind the form, there's this structure. And one last thing I think is that it's amusing. We thought at some stage, or it was tried out to do use LLMs. I think this was a while ago. They weren't so hot, so it might be different. And there was a real problem with this because this 1OT here with maximum and minimum, it kept on getting it wrong because it assumed it was something to do with maximum and minimum. So it kept on having to change the prompts to try and get it to go right. Eventually we got it to work, but it was a lot of it wasn't a the cost of prompts was just getting too high to make this viable. And if you think that this was an issue with data and you could get all these things all over the place, and how would you spot them as a problem? So LLMs weren't viable really at this stage for this kind of thing. There were bits of it like the names where we use them at each stage, but trying to do the whole extraction, just we haven't been able to see a way of doing it yet. Okay, I'll stop now.